Okay, so we are moving on to the real part of this unit, which is the two different types of distributions that we have. So we're going to talk a little bit at first just about how we've calculated probability in the past, and then what is so different about binomial distribution, which in reality is something we've been talking about, just didn't know it for a while now. So first off, a cereal company puts miniature figures in boxes of cornflakes to make them attractive for children and thus boost sales. The manufacturer claims that 20% of the boxes contain a figure. You buy 3 boxes of this cereal. What's the probability that you will get exactly 3 figures? So that means that you got one in the first and in the second and in the third. So what operation are we going to use here to calculate the probability? Hopefully you said multiplication. Since it's going to be in the first and in the second and in the third, that 20% needs to be multiplied by 20%, again by 20%. So then that's going to be 0.2. Remember that we need to use our decimal version for probability. Multiplying those all together, we get 0.008. And that's it. With B getting exactly 2 figures, I think it's easier if we visually represent this as a tree diagram. So we can see kind of what's going on and which branches of this tree end up with having only 2 figures. So I'm going to have a figure and then no figure. And then this level is for this level is for the first box, and then we need to talk about the second box. And then we need to talk about the third box. I think hopefully you feel confident at this point being able to fill out the tree diagram with all of the probabilities. The probability of having a figure is 0.2. Thus, the probability of not having a figure must be 0.8. Okay, go ahead and fill out the rest of this tree diagram. Going through, now we need to go back and look and say, okay, well, which of these gives us exactly 2 figures? So we can understand that it's this probability of getting 2 figures is 20% times 20%, and then the last one would be the probability of not getting a figure would be 80%. The trick here is that there's multiple instances where that could occur, right? You could get 2 figures and then not a figure, or get a figure, not get a figure, and then get a figure again. So all of those ways in which you can order it get messed around. And so a tree diagram might be a good way. Maybe hopefully making tree diagrams is a little bit quicker now than it was in the past to visualize what situations or how many of these situations occur. So getting 2, I'm going to first follow figure, figure. I can't get a third figure, but a not figure would work. So I'm going to put a star next to it. Figure, not figure, figure would work. But figure, not figure, not figure would work, not work. Okay, not figure would only work if the following 2 were figures. And that's it. So there's only 3 situations in which you could get exactly 2 figures. So in order to find those out, we need to find each of those probabilities, which is just 0.2 times 0.2 times 0.8, which is 0.032. 0.2 times 0.8 times 0.2 is going to be the same thing. As we talked about earlier, those probabilities are all going to be the same, but our tricky part here is knowing how many times it occurs. So we're going to take this guy and multiply it by 3, because there were 3 separate instances in which that probability happened. That ends up being 0.096, not even yet a 1% chance of getting a figure. Okay. Oh, sorry. A 9% chance. Yeah, my brain was dead. It's definitely a 9% chance. So that's a pretty high, no, it's not. Exactly 2 figures in 5 boxes. So making a tree diagram maybe made sense for B, although it does probably seem like a little bit of a stretch that maybe you could figure it out on your own what the different combinations are. Definitely dealing with 5 boxes here is too much to do with a tree diagram. So what we want to do is we want to list out all of the instances in which we could have 2 figures when we have 5 trials or 5 instances, 5 boxes that we're looking at. I'm going to actually shift around my notation because with this, I want 2 letters that look different. Just because it makes it easier for me to visualize what's going on. Because if I had a bunch of F's and F primes, I think I would get confused, which means that I think maybe some of you would get confused. All right, so we want to have 2 figures in 5 boxes. So that could manifest as figure, figure, not figure, not figure, not figure. That could manifest as figure, not figure, figure, not figure, not figure. I'm going to move that second F around down the line to try and cross off all of the boxes of possibilities, right? So I'm trying to organize this in my mind, and I'm sure you guys all have your different organizational system, or if you don't, maybe start trying to recognize how your brain processes these types of questions when you're asked to say, what are all the different possibilities of these things coming out? Well, I'm going to solidify, I'm going to keep this first F there and then figure out what are all of the different iterations of having this first F here. And so then I can keep moving the second F down. And then again. Now I've done all of the different iterations, all the different possibilities of that first F being there. So then now I'm going to move the 2 F's over. So what if I did N and then F, F, N, N? So now I've got this first F in the second spot and try and do all the different iterations, all the different possibilities. Now that I'm done with those possibilities, again, I'm going to move this first F down. As you notice that the different possibilities of keeping one in place and then moving the second one around starts to get less and less as the further you kind of get to the end. Now as we get to this part, this is our last option. You can't flip those F's around because it would just result in the same thing. So we're done. So there are 10 different possibilities of these combinations where there's 2 figures in exactly 5 boxes. And so how that works when we're calculating the probability is no matter what, F will always be 0.2 and N will always be 0.8. And so no matter what's happening, we're multiplying 0.2 by itself twice. So I'm going to square it. And I'm multiplying 0.8, the probability of not getting a figure, by itself 3 times. So that's to calculate just one of these guys. 0.8 times 0.8 times 0.8 times 0.2 times 0.2 is this situation represented right here. But we have 10 instances in which that could occur, 10 separate instances where that could occur. So we multiply it by 10. The final result is 0.2048.